In this example, we will create some manual dynamic simulation joints to get a clearer picture of just how they are created when we use the automatic settings. So I'll go to environments and I'm going to go to dynamic simulation, and on the simulation settings right now it's set to not convert the assembly constraints into joints. You'll notice everything is over here in a grounded group. We don't have a mobile group. So we want this shaft to rotate, and that would only have 1 degree of freedom, then a revolution joint. And there's a work plane put into this shaft at the distance of this base part, the grounded part down here. So this work plane is in this shaft part. So I'm going to insert joint, and I'll do a revolution joint, and I'll select component number 1. Notice the origin of this component is here in the middle of the part. If I put this for the second component, I would have to have that same origin, or it would move this shaft because it's going to combine those two origins together or align them. So I need to define the origin in this case. So I'm going to define that origin as the intersection between this plane and the axis. So it moved that coordinate system for the origin up here to the to that plane, and then I could, if needed, I could change a direction for z-axis in this case, or the x-axis. In this case I don't need to. I could also flip the z-axis if I needed to. And then I'm going to select component number 2, and I'm going to select the circle on the edge of this grounded part, and it will automatically put the origin of that circle at the center of that circle. And then I see that the z direction on this one is going in that direction. I need to line these up. If I don't, it's going to flip my shaft around to the other side. So I'm going to line up that z-axis, and if I needed to, I might change one of the x-axes to try to line it up as well. Now sometimes it might be off just a little bit, in which case it would rotate this shaft to line up the x-axis. In this case they happen to be lined up perfectly. But I'll go ahead and say OK now to create that revolution joint. Next I want to put in a joint for this component, and we want this component to be able to translate or move up and down, and initially we'll allow it to rotate as well. So a rotational and translation degrees of freedom would be a cylindrical joint. So we'll do insert joint and we'll do cylindrical, and then I'm going to select as component number 1, I will select this part, and I want to move that origin down to here. So I'll select down here for the origin, and then I'll go to component number 2 and I'll select this part, and I want that origin to be up here. So I'll select up here for the origin. It moves those origins together. The X, Y's, and Z's are lined up. So I'll go ahead and I'll say OK to that. I also want to put a cylindrical joint up here as well. And so I'll do insert joint and I'll do cylindrical, and I will select this component. It puts the origin up here. I really want it at the intersection of this plane, which is in that part, and the axis. So I'll click on this plane. It moves the origin down to there. I'll do component number 2 and I'll select this component. We see the origin is down here. I need to move it up, and so I'll select this circle at the top here. It moves that origin up, and I would like to get these coordinate systems better aligned if I can. I may or may not be able to. The z-axis is lined up okay. We'll try to flip the x-axis and see if that lines it up, and that doesn't really line it up any better. It's slightly better. Well, it's a judgment call. Here it would have to move all the way over here to line up that x-axis. Here it would have to move that distance, so that's the shorter distance. So if I say OK, it's going to rotate this component around because the back plate is grounded. So it's going to rotate this shaft around until this X is lined up, until the Y coordinates are lined up. So if that's an issue, consideration of how to do this might need to be taken. In this case, it's fine, so I'll say apply to that, and now it has lined up the y's and the z's. The z was lined up, and the x and the y's are now lined up on that shaft. Normally we would allow this roller to rotate around this pin, but in this case, to simplify our assembly, I want to weld this roller, the follower, and the pin and this shaft together into one component, or so it'll treat it as though it were one component. So I'm going to select this part. So I'll select this part, and I'll hold down the control key, and I'll select that part, and I'll select that part. Or you could come over here in the browser and select those three parts. And then I'm going to right click. I'm going to say weld those three parts together. So now those two parts that were up here in the grounded group are moved down into the mobile groups, and we see that the three parts are part of a welded group. In the next joint, I want to keep this spherical feature against this planar feature on top of the cylinder. Now we're going to fudge a little bit on how we do that. If we go to a wireframe view, we see that there is a point in this spherical feature at that location, and we're going to do the same thing over here. There's a point over here. So we're going to keep this point against this planar face. That isn't really technically correct, as this part moves, the contact point doesn't stay at that point. It moves along this curve here or here, in the same way on the other side. But for the purposes of this demonstration, we're going to fudge a little bit on that, and we're going to keep that point against this plane. And so you may do it in wireframe view, or you may do it in shaded view, whichever is easier for you to do. I'm going to go back to shaded with edges, and then I'm going to insert joint, and so I'm going to do a point plane joint. So here's point plane. I'll select component number 1. Now notice it says for component number 1 we want the plane, and for component number 2 we want the point. So we'll select these in the correct order to get the plane. So I'll select this plane for my first selection, and then I'll go to point, and the point is down inside there. Now you may need to right click and do select other to get that work point, and so now I have that point, and I'm going to line up these coordinate systems more or less. I see Z's going in the more or less same direction. I'm going to change the x-axis on one of these, and so now I see X is lined up and Y is lined up more or less. I'll say apply to that, and then I'll do the same thing over on the other side. So I need to select my planar face first, okay? And then I will get the selection tool for the point, and I'll let my mouse rest there for a second, or right click, and I'll get that work point. I'm going to flip the x-axis on this. So now X is lined up, Z is lined up, Y is lined up, and I'll say OK to that. So I have that second point plane over here. Next I'm going to define the direction for gravity. So I'll come over here to external loads and expand the external loads, and I'll right click and select define gravity, and I could either select this plane or the plane on the bottom, or I could select one of these vertical edges, and I'm going to select this plane on the bottom, but it really doesn't matter. That'll put it perpendicular to that plane. I'm going to flip the direction so that gravity is pointing down. I'll then play this in motion, so I'll play it, and we see that it moves under gravity, but our mechanism is unconstrained. So we don't have a cam in here to drive this follower. So I'm going to define the motion of the follower, and then we'll work in reverse to define the cam that will give us that desired motion. So I'm going to go to the cylindrical joint for this part. So I need to make sure that I have the correct cylindrical joint. And so I'll right click on this and I'll go to properties. Now yours might be in a different order if you created them in a different order. Make sure you have the one for this part, and I'm going to go to properties and I'll go to degree of freedom translation. So it has 1 degree of freedom translation and 1 degree of freedom revolution. Let's go to this degree of freedom translation and notice that there is a number here, an offset value that is in here, or a position value that is in here right now. I want this number to be 0, but don't type in 0, because if you type in 0, it's going to move this cam to wherever 0, or the follower to wherever the 0 position would be. I want it where it is right now. I've already set it where I want it to be. I want that to be the 0 position. So I'm going to right click, I'm going to select this select offset. And so now it put in an offset to say that that's the 0 position. I didn't type in the 0. Don't type in the 0 or it will move it. And then I'll go to impose motion and enable it, and I'm going to do this as a position so I know how high I want that to move and when I want it to move. So I'll do position, and then I'm going to select the input grapher, and I'm going to put some timing in here, a displacement diagram for how far I want this to move and at what particular times. So as my starting point, I start at 0, and again I want this to be the offset, so I'll right click and I'll tell it the initial position. Don't type in 0, tell it initial position. And then for the ending position at 1 second, I also want that to be 0. Right, then I'm going to click about right here and I'll add a new point. And so this segment in between here and here is my active segment. If I select back previous sector, I'll go forward sector. Now it might jump, so this was where we started at. And then this point, I want that to end at 0.45, and I want it to stay 0 from here over to that time. So I'm going to set this at 0 down here. Okay, so between 0 and 0.45 it dwells. I'll add another point here, and so now this segment is active. We can see the yellow highlight that's active, and I'm going to go to 0.52 on my time, and I want that then to go to 2 millimeters. I will add another point, and I want that point to go to 0.57. Down here I want it to be 0.57. It's starting at 0.52 where we left off, 0.57. And I want it to dwell at that 2 millimeters, so I'll put in 2 and tab. So it starts out dwelling at 0 to 0.45, then between 0.45 and 0.52 it goes up 2 millimeters, it dwells at that 2 millimeters, and then we'll come back down. So I'm going to come over to this segment, and I want that to end at 0.62, and I want it to be at 0, and I want to make sure that it stays 0 to 1 second. So I'm going to add in another point. I'm going to tell it that to end at 1 second. I'm going to make sure that it's at 0, and so there is our graph. Now we see that we have a straight line motion between here and here, and a straight line motion on our fall. So on our rise and fall, I would prefer to have a smoother curve on that. So I'm going to click back here in this segment, and you can either click in the segment or you can cycle through the segments here. And where it says linear ramp, I'm going to tell it to do a cubic ramp, but I need to move that law over into the motion. So I'll move that over and replace the linear ramp with the cubic ramp. And now notice that's curved here, a smoother curve. I'm going to do the same thing over in this segment. So I'll go over to the fall segment with cubic ramp. I'll replace the linear ramp, and so now we have a smoother curve on the fall for that. And so I'll say OK to that. Having defined our motion, I'll say OK to that. I'm going to test this out, so I want to watch the motion of this follower. And so I'll play this, and it says that it goes down and then back up. Let's slow that down a little bit by doing more calculations. Let's do 1,000 calculations, and I'll play this again. And when we watch this follower, that might be too slow. It's going to take too long here for it to go down. So it goes down. Notice it's going down into this part. Now yours may or may not be going in the correct direction. So mine's going in the wrong direction, so I need to flip the z-axis for that joint. So I'll go over here to that cylindrical joint and I'll go to edit, and I'm going to flip the z-axis on both of these segments of both components of that joint, and I'll say okay to that, and then we'll play this again. Let's speed that back up. So I'll go to, let's say 200, and I'll play this. And so now it goes up and it comes back down. So it dwells. At first it dwells, there's no motion, then it goes up and then it comes back down and it dwells. So now we have our correct motion for that joint. I want to create a trace to follow where the center of this follower translates to or moves to. And if I check the diameter or radius of this follower, so I'll go to the inspection tab and I'll measure this, and I see that it's a radius of 5 millimeters. We'll need to remember that number because the distance, we need the distance from here down to here is that radius of 5 millimeters. So I'll go back to dynamic simulation and I'm going to put a trace on here. It asks me to select an origin. I'm going to select a circle, or I could select a cylinder. It'll find the center of the circle, and I want to not just display that, I also want to record that trajectory. So I'm going to check mark here the trajectory, and I want that reference to the grounded component. I'll say okay to this, and so we see the display of that trace. There's a straight line where this goes up and down. Let's play it again. So I'll play it again. So initially it dwells, then it goes up and comes back down. So here is that trace displayed as a straight line. But that doesn't give me my cam. That only gives me the displacement. So I also want to get the displacement relative to the revolution of the cam. So I'm going to put an imposed motion on this shaft to cause it to rotate. So I need to find that revolution joint. I will right click and go to the properties. It has 1 degree of freedom, revolution. I'll do an imposed motion, and I want to go a constant velocity of 360 degrees per second. So if I run this for 1 second, it will go 1 revolution. I'll say okay to that, and then the number of points that I calculate as this rotates around is this number right here. And so the higher I put that number, the more points it will calculate. So if I did 360, it would do 360 points. I'm going to do 720, so every half a degree it will create a point. If I want that number larger, I can set it to be larger. And now I'll go ahead and say okay to run that. And so initially it dwells, and then as the follower moves up and it moves back down. Now I didn't get the trace of the cam like I was expecting because we're tracing this relative to the ground. So let's go back to this trace, and we'll need to open up the output grapher to do this. So I'll go to the output grapher and I'll go to the trace, and I'm going to right click and edit that trace. And so rather than reference grounded, I'm going to select this relative to the cam rotating shaft, and I'll say okay to that. And so now we see the path traced out of that cam. If I wanted to, I could rewind that and play it again. So let's just do that. So let's rewind it and play it again. So it's going to trace out those 720 points. So right now it's just a circle, and then as this starts to move, it puts in the offset value of our cam. Remember, the cam is actually, the follower is down here, 5 millimeters. Okay, now that that is complete, I'm going to right click on this trace and I'm going to tell it to export that trace to a sketch. And down here it tells me to select the component that we want that sketch to be in. I want that sketch to be in this part, so I'll select that part. So put that trace into this part. I'll now right click on that part and open it. You might need to set your selection priority on part priority. In my case, I was able to get it to open. Now I have my points set to be pretty big. Yours may not appear the same if your points are set smaller. Then I'm going to extrude this, and I'll get that area, and I'm going to go back in the other direction, and I forget what the distance is. I want either 1 or 2 millimeters. Let's see what 2 looks like, and I think that might be the same thickness. What I'm looking at is how thick is this distance from here to here. I think it's 2 millimeters. We'll go back and measure it later. All right, so I'll go back to my part and I'll say okay to that. And actually, if I go back here, I need to put in that offset distance, so I need to do this part over again. So I'm going to come back here and I'll do undo, and I'll edit that sketch, and then I'll do offset, and I'll select that curve, and I want to offset it 5 millimeters towards the inside. That was the radius of our follower, and then I will extrude that. Now you may want to change this original curve into a construction line type, and then I'll do my extrude, and I'll select this area, and it's not selecting the area. Not sure why it's not selecting that area. Let me see if I can solve that issue. I'm not sure why Inventor is not allowing me to extrude this, but I'll go to extrude and I'll put it on surface body instead of solid body. Actually, if I select this and put this on solid body, it comes up with the red cross that I could try to figure out what the problem. It tells me is there's no closed loop, but there should be a closed loop. And so I'm going to run the sketch doctor, and so I'll do finish on this, and it's still not allowing me to do that as a solid body. So we'll try this. I'm going to change this to a surface body, and I'm going to extrude that going back a distance of 2 millimeters, and then I think it's maybe seeing an opening right there. I'm not sure. And then I'm going to put a patch. I'm wondering, did I run that enough degrees? I'll do a patch. I'll do a patch back here, and it found that as a closed area, so I'll do apply to that. And now I'll do another patch up here, and I'll say OK, and then I'm going to stitch those or sculpt those together. So let's try stitch first. So I'll select these 3 surface bodies, I'll say apply and done, and so that worked to convert it to a solid. I'm not sure why I was having an issue. I never had that issue in the past, but actually I see that it's 2 solid bodies here. I want that to be as 1 solid body, so I could do that as sculpt instead, or I could just combine these 2 solid bodies. And I'll save this, and I'll go back to my assembly. So now we've used the displacement diagram to generate a cam. We no longer need to drive this with the displacement diagram, so I will uncheck enable impose motion on the translation joint for this shaft, and then I'm going to put a joint in here between this roller and the cam. Now we set this roller as welded to the rest of these 2 parts, and so it doesn't rotate. In the real world we would probably have this rotate, in which case we would do a rolling cylinder on curve. In this case, because we have it constrained welded together, we'll do a sliding cylinder. So I'll do an insert joint, and I'll do a sliding cylinder on curve. Okay, sliding cylinder curve. It asks me to select the curve and then the cylinder. To select the curve, I'm going to select this edge right here, and because I have actually an edge down here and an edge up here, I'm going to pick this a second time to make sure I get that edge. And then the cylinder, I'll select this edge of the cylinder, and because I selected that circle there, the origin is already at the center of that circle. And I'll say OK to this, and then I'm going to run this, and I think I'll do 360 calculations, and I'll run it for 1 second. So I'll go to my joint, make sure that I have that set to go 1 revolution or 360 degrees per second. So 360 degrees per second velocity. I'm going to run it for 1 second, so it should do 1 revolution. So I'm going to go ahead and run this. Now right in here somewhere we may get an error. Okay, so we got an error. It says the parent frame of the loop Basically what that means is the coordinate systems are no longer lined up properly. And so I'm going to say OK to that. And so what's happening then is, as it hits right here, this is a cylindrical joint, not a revolution joint or a prismatic joint. So this thing can revolve. So it can translate and it can revolve. We don't want this shaft to revolve. So we could either do that a couple of different ways. We could set this up in such a way that it was a prismatic joint rather than a cylindrical joint, or we could just go to that cylindrical joint, and I'll go to the properties of that cylindrical joint. And so I want it to translate up and down, but I don't want it to rotate around this z-axis. And so I'm going to lock that degree of freedom of rotation. And now when I play it again, it will give me a warning first that I have a locked degree of freedom. I know that I did it on purpose, and so I'll tell it to continue. And so now we see that it revolves. Now you may need to increase the number of calculations because when we get into this area right in here, it could still have trouble determining the contact if our number of calculations are too low. So it made it past that first area, and but when it got over into here, it looks like it's having trouble calculating that location. So I'm going to, when you get an error like this, the first thing I would try to do is increase the number of calculations. So I'm going to do that, and I'm also going to turn off this trace. So let's rewind that. I'll go back to construction, and to turn off the trace on the output grapher, if I expand this, drill down to the traces, and I'll right click on that trace, and actually it's grayed out here, so I might have to play it for a second or so. So I'll just play it, and it gives me again the warning that we have that locked degree of freedom. And I just need to play that long enough to get this where it isn't grayed out. And then I can either delete that trace, or I could edit the trace, and I could unselect the display trace. So either way. Alright, so I'm going to increase the number of calculations, and hopefully it gets past that point where it hung up. I'll also turn off the visibility of any work planes or work geometry. So I'll go to object visibility. I'll turn off all work features to make my screen look nice. I'll increase the number of calculations here, and so let's do say 720, and I'll play this again. Now it's going to be slower. Hopefully it'll go all the way around. Again, the warning about locked degree of freedom. One thing that you can do to speed things up is tell it not to display the motion I can deactivate the screen refresh, let it do the calculations, and if it's going to freeze, then we know we need to increase the calculations again, and not display the motion until after we know that it's actually going to work. And so it looks like it had an issue again, and we may even have a problem with the geometry. We might have to find a different way to get this to work. Let's try one more time. And so I'm going to put this to 1440, and I'll try playing it again. Now it gets so slow that I might give up on this, but you can keep experimenting until you get it to work. Remember back when we did this cam, also we did this as surfaces, and we should have been able to do it as an extruded solid, and I'm not convinced that there isn't an error in my geometry because of that issue as well. Well, I'm still getting an error, so I would probably backtrack to where I created that cam and try to do the entire mechanism over again. I think we've introduced an error at some point.